Phew, that's enough outside time for today. So what's this camera that I'm using? It's called a Pica camera, and I designed it using the Raspberry Pi and a high-quality camera module. It's a 3D printed, interchangeable lens camera based around the Leica M mount. I named it by mashing up Pi for Raspberry Pi with Leica. Pretty unoriginal, but I'm a sucker for the pun. The design takes inspiration from the wedge shape of a Polaroid, while the front is a cartoonish rendition using classic Leica colors: white, black, and of course red. Let's get a closer view of the camera hardware. As you can see, it's not small or compact, but it does fit in the hands. If we turn this to the front, we can see the lens and the lens mount along with the shutter button. The shutter button uses any kind of Cherry MX style switches that are made for mechanical keyboards. So you can customize the camera to have a clicky, tactile, or linear button. There are just so many to choose from. This also means that you can have a custom shutter button keycap. The combinations are endless. On the bottom of the camera, we have the standard 1/4 inch tripod adapter and the storage compartment. This is where the USB drive is stored, and we can pop it open with a fingernail. We can then open the storage door and we see a USB drive. This can be removed like so and plugged into a computer or an iPad with a USB-C connector. So let's put that back and close up the storage door like so, and it's locked in place. Moving on to the side of the camera, we see the I/O. This includes the charging and serial USB-C ports, 2 micro HDMI ports, audio and analog video, a master power switch, and a soft power button. Now, let's turn this thing on and check out the user interface. This GUI is the main UI, with the left being the live view of the camera and the right being the controls. We can use the on-screen controls to take a video or capture an image. We can change the video mode between a couple different resolutions or exit the software. The camera also starts up in full auto exposure mode, but we can change manual settings. These include the ISO, shutter speed, exposure compensation, and auto bracketing. We can also see the battery percentage as well. So now let's take a photo with the shutter button. And if we want to exit out of the software and shut down the Raspberry Pi computer. That's the basics of the camera, but what's the real secret behind the design? Let's talk about sensor crop factor. It's basically the result of using a smaller sensor on a lens that is designed for a larger sensor area. You may have heard about crop factor in reference to APS-C cameras when using full frame lenses on those bodies. The crop factor, or the ratio of sizes, effectively translates to a focal length increase. Here we can see the APS-C sensor encompasses a zoomed in portion of the full frame sensor equivalent. So since the Pica camera uses M-mount lenses that are designed for full frame sensors, what size sensor are we working with? Well, unfortunately, it's tiny. The crop factor is over 5 times the original focal length of the lens, which is a huge problem. This means that a normal 50mm lens becomes a whopping 275mm lens. There's no way I can use that for street photography. So how do we solve this problem? Well, we can't really solve this, but we can mitigate some of the effects of the crop factor. Now, it's time to reveal the secret ingredient. Let's see what's inside. It's just a common magnifying glass. Add a focal reducing lens in between the sensor and the lens. Focal reducers are very common in the world of astrophotography. This is because lots of telescopes are designed with really long focal length lenses, which naturally makes sense. You want to see stuff very far away. But what if you wanted to look at something like the moon, which is relatively close when compared to other celestial bodies? The moon would be way too close and you would not get the whole thing. By using a 0.5x focal reducer, we have reduced the focal length of the telescope, letting us see or take a picture of the whole thing. But what is a focal length reducer lens? Here, we have a common 0.5x focal reducer attached to the Pi HQ camera. Compared to the original, this one is slightly magnified. That's basically it. It's a simple magnifying glass. What's really happening with these lenses are that they are shortening the focal distance to the image plane. As we can see here, by adding a simple convex lens, the point of focus moves closer to the original lens. This means that if we put our smaller sensor in the optical path, it will cover more of the optical focal plane, where it was only capturing a small portion before. In the world of photography, you almost never hear the word focal reducer, but you may have heard the term speed booster. They are one in the same. And as with speed boosters, adding the focal length reducer to the design increases the amount of light hitting the sensor, effectively increasing the f-stop by the same reduction factor. Pretty neat stuff. So now let's take a look at the internals of the Pica camera. So what I'm going to do is turn this to the side, take off the I/O plate, remove the top shell, being careful of the cable. Then I'm going to remove the shutter GPIO plug and remove the camera CSI cable. Then what we can do is slide the front and place it down like that. From here we can see all of the electronics, or at least most of them. We have the Raspberry Pi 4 that powers the whole thing, a cooling fan to keep the Raspberry Pi 4 from getting a little too toasty. We have our Pi Sugar battery management board that's underneath, along with its battery. The battery is a 5,000 milliamp hour or 18.5 watt hour lithium battery. We then have the battery monitor, which is an AT Tiny 85 microcontroller, along with a custom voltage divider to allow it to monitor the battery's voltage correctly. On the front of the camera, we have the sensor board that's mounted into the lens mount. We have our shutter button. That's just a standard Cherry MX compatible switch. We then have, if we move this cable out of the way, we have our GPS module that's connected via USB and this ribbon cable to the Raspberry Pi 4. And then underneath, we have a second USB going to the storage that sits below the Raspberry Pi and Pi Sugar battery management board. So now let's get this all closed back up. You can also buy almost all of the electronics. I purchased the majority of my parts off Amazon. Prime shipping was a key player in making this come together so quickly. And there we have it. That's the Pieca Camera electronics. So should you buy this camera? Well, no, you can't, because this one's mine. I built this one myself, but you can build your own. All of the software is up on my GitHub, as well as the 3D files that you can use to build it. Learn more about the technical design on my blog post at tandtechtime.com. In the end, I'm just a camera nerd that loves taking pictures and making things as well. The possibilities are endless. With this device, you can write new user interface, code up a new image processing pipeline, adapt new lenses to the camera, modify the optics to do IR or UV photography, and much, much more. So get out there and make some stuff. Thanks for watching this video, and I hope you enjoyed it. If you liked the video, please like and subscribe for more content like this. For now, I'm gonna go take more pictures and treat myself to another cup of tea. Cheers.